This is Levi Kamara and I am your programming tutor. I've been away for some time because of some app I've been working on, but now I'm here again, and let's continue from where we left off. In the last lesson, I taught you loops, right? Today we're doing lesson 9, and I'll be teaching you functions. And we're going to do some practical examples at the end where we will use loops and the new concept of functions. So let's start quickly. What is a function? A function is basically a reusable block of code, and it can help you simplify your program. An example will be, let's say you could say, let's sum equal 1 plus 2, right? You could do this, or I tell you find the sum from 1 to n, where n is equal to 20, for example. You could decide to write a for loop, and you say for let I equal 0, I is less than 20, 20, go for I plus plus. And then you will do sum plus equal I, right? We start from 1 and then go up to 20. Well, you already know what I'm doing here because you have been following, I assume. And then in the end, you console log the sum. You see, what happens if I tell you I want you to do the same thing from 1 to 50? Or if I tell you, no, I don't want you to take the sum from 1 to 20. I want you to take the sum from 30 to 50. So you see these requirements, and you have to rewrite the same code, and that kind of will make your code not clean. Okay, so this is where function comes in. A function allows you to write this functionality such that it is reusable, and you can have different parameters to customize the behavior. Okay, so for this case, we can decide to write a function called sum. So now let's go into defining a function. Defining a function in JavaScript, you can use the function keyword, and the function, and then you give the function name, as you can see here, and the arguments, and then you can return something or you can return nothing, right? And a function that does not return anything is called a void function. There is another syntax for doing the same. You can say constant function name is equal to, and then you use the arrow function. So we are going to do that in our example. Okay, so we're going to create another function that calculates the sum from the beginning to the end, meaning we will specify where we are going to start calculating the sum from to where we will end calculating the sum. So to do that, we're going to create a new function, and we will say function get sum, and now pass the parameters. What do you expect this function to take? We expect the start and the end inclusive, right? And then what do we return? We return the final sum. So we can say return sum, but you have to declare sum up here. So we're gonna say let sum equal 0. Then now we can do our for loop. For let I equal start, okay? I is less than or equal to end, okay? Go for I plus plus, and we will increment the sum by I. And this is it. This function will get the sum for us. So to show you how we can reuse this, we are going to say console.log get sum from 0 to 20, right? This is 1, but you can also get the sum for so many other numbers. Let's say from 30 to 50, or from 24 to 29, okay? Or from 90 to 120, or from 50 to, okay, let's do from 50 to 40. Now this one will not work because the start has to be less than or equal to the end. So it will return 0. So let's try to run this program and see what we get. Lesson, say 9, okay. 9.js. And there you see, that's giving us the individual sum. And you see the last one is 0. Why? Because 50 is less than 40. It's greater than 40. But what have we just done here? We have written a function that takes in two numbers and gave us the sum of all of the numbers from the start number to the end number. And we can reuse this function throughout our code. You could define this in another way by saying constant get sum is equal to this, and then you use the arrow here. It's the same thing to still be the same old function. So this is how you declare or you define a function in JavaScript. So these are called the arguments, or the parameters actually. When you are defining the functions, these are the parameters. But when you call the function, these are no longer called parameters. They are now called arguments. Okay? They are now called arguments. Great. So I've shown you how to call a function, and here you can see this is how you call a function, just the name of the function, and then you pass the arguments to the function. So let's talk about scopes then. So what are scopes? Well, scope is basically the context in which you can access certain programming elements. Now, when I say programming element, remember initially I told you programming elements include variables, functions, classes, all of these different elements, right? And we talked about that when we were defining identifiers. So now this name is an identifier. It is used to identify this function to the computer, or it's like an ID, right? Right? Good. Now that you know, scope is like saying if this function is defined here, you cannot access it somewhere else. Now, there could be other elements, for example, variable. You see, we said let sum equal 0. This variable sum cannot be accessed outside of that function. It is not available outside of these curly braces because it was defined in here. Hence, this variable is local to this function, and that's what we call local scope. Okay? This variable is local to this function. Good. So then what is a global scope? Well, the function itself is in the global scope. So I can come down here and access this function. In fact, I can write another function that will access that function. For example, let's say we write another function that says multiply the sum. Okay? Multiply. And this one takes in two numbers, start, end, and it will multiply. It should be multiply. Okay? It will multiply the start by the end, and then it adds the sum, something like that. I just want to show you what a global scope looks like. So we're going to say return start times end plus, or maybe let's do times, get sum from start to end. So you see, get sum is accessible inside of the multiply function. Why? Because this get sum is in the global scope. So anything that is in the global scope is accessible throughout the program. Then we talk about block scope. Now, block scope is JavaScript specific. And what makes block scope different is that if I do like this and declare a variable in here, for the fact that this block exists, indicated by this curly brace, you cannot access name outside here. You can say name. It's not the same as the one in here. This one is limited to this block of code. So that is block scope. So if you have an if statement, like if x equal 2, if x is equal to 2, and then you say let name, right, equal John, well, name cannot be accessed outside of this if block. Name is block scope. Okay, that's basically the whole concept of block scope. So that is local scope, global scope, and block scope. Well, let's move on to our next section of this tutorial. we are going to look at now default arguments. So what are default arguments? So default arguments are the values that will be passed to the parameters by default in case you didn't provide an argument when you were calling the function. For example, if you want to define a default argument for start, we can say start is equal to 0, and our default argument or default value for end will be 10. Okay, then if I come down here and just say get sum without passing any argument, then automatically start will be 0 and end will be 10. So this will give me the sum from 0 to 10. But if I pass something like 5 and 7, then that's when these will be overwritten. Okay, so that is it for default arguments. So we have some few examples that we are going to do, and I'm going to just delete these. And first of all, let's start with our first exercise, the exercise that you are supposed to do from the previous lesson. So the first one says, given two numbers n1 and n2, find the greatest common divisor. So we are going to create our function. So we're going to say function, right? Find GCD. It takes in n1 or num1 and num2. We are expecting these numbers to be integers, okay? So they should be integers. Now, we are going to create a very inefficient algorithm, but the concept here is to just allow you wrap your head around loops as well as functions. So we're going to say let our, GCD by default be equal to 1, because we know 1 can divide every single number, okay? And if you don't know what a GCD is the greatest number that can divide both number 1 and number 2 without remainder, okay? So how do we do that? We can say, let's just do for, I'm thinking, we can go up to half of the two numbers, okay? So we can say let k, which is our count, starts from 2, okay? Let k starts from 2, and then we're going to say why k is less than num1 divided by 2, because we know no number can be divided by more than half of itself, okay? And k is less than or equal to num2 divided by 2, then we want to do something here. So what is it that we want to do? Well, we just want to know if it can divide both of them. So if I want to show you something about continuum and break, but I will show you that later on. Here I'm going to use I think I explained the whole concept of continuum before, like continuum and breaking. Okay, so you can use continue or break here, but by default, after this loop terminates, we should have the GCD being found, something like that. So we would say if num1 %k is not equal to 0, or num2 %k is not equal to 0, then what should we do? Continue. Don't go further. Just go increment. But well, this won't really work well because of the fact that we have to increment k. Okay. So in that light, let's take the positive logic instead of the negative logic. So if it can divide both of them instead of not equal, we say if it is equal to 0 and num2 is equal to 0, that is num2 %k is equal to 0. Remember, this percent is the modulo division. We know if a number can be divided by another number, then if you take the modulo of the factor and the multiple, then you should get 0. Okay, so this is the modulo division. Great. So that means GCD is equal to k. And after that, we will increment k plus plus. So the only time we are going to update our GCD is when we find a number that divides both of the two numbers. And once we're done, we can return GCD. So this will find the GCD of two numbers. So let's test it. We can say console.log the GCD of, we know the GCD of, let's say 15 and 10 should be 5, okay? 15 and 10 is, and then we do find GCD of 15 and 10. Great. If we run this thing, we should have, let me just clear this console here and pull it up. Then let's run it. There you go. The GCD of 15 and 10 is 5. Good. So we have just used the while loop. You can use this thing with the for loop, and we are going to have the next example done with the for loop. Okay. So now we have a function that gets the GCD. Let's have the next function. Number 2 says, given a string S, determine if S is a palindrome. So what is a palindrome? A palindrome is a string that spells the same both even when it is reversed. For example, we can spell Anna, A-N-N-A. If we start from the back, it will still be A-N-N-A. Okay, so this is a palindrome. However, Levi is not a palindrome because L-E-V-I is not the same as I-V-E-L. Okay, so now we need to check if it is a palindrome. So we're going to say, create a function. Function is palindrome. Now, notice my naming convention. Okay, remember you want to give names that makes it easier for you to understand your code. This thing about commenting in your code is good, but you want your program to document itself. Okay, so is palindrome takes in a string S, which is going to be some kind of word. So it's going to be a word, and then we have to iterate from the beginning of this, like for every character in this word. Now we will talk about arrays later on, but word or strings are actually array of characters. For example, Anna is an array of character. The first letter is A, the second letter is N, the third letter is N, the fourth letter is A. So in terms of array and zero index, you say index 0 is A, index 1 is N, index 2 is N, and index 3 is A. Great. So that means if this is a palindrome, then A here should be the same as A here. Okay, that is the beginning should be equal to the end, and you make it smaller. Come here. This one should be equal to this one. Okay, so we are going to have our for loop that will start iterating from the back of the string and the front of the string. So for every iteration, we check if the two the characters at those two positions are equal. If they are not equal, then we return false and we break. Okay, or we just return false. So we are going to say for let I be equal to 0, that is the beginning of the word, comma, j is equal to word dot length minus 1. That is going to be the end of the word, because the length of this word is going to be 4, but remember we start from 0, 0, 1, 2, 3, so 4 minus 1 will be 3. That means we are going to be at the last character. Okay, then we will say yi is less than j. You go for I plus plus, right, and j minus minus, because you'll be bringing j down as you are taking I up. And we don't really care whether I is less than or equal to j, because once they meet in at the same letter, right, if this thing is odd, let's say A, N, N, I, N, A. So even if I is here and j is here, as long as they are equal, then we don't care what will be in the middle. They'll still be the same. So if this thing is odd, we know it will spell the same. So that's why I didn't say if I is for, I being less than or equal to j, you should continue running. So we don't really care about that. Now this is some data structures and algorithm. Okay, great. So we just want to say if word at I is not equal to word at j, then you want to return false. So you see we are returning a boolean. But if we execute this loop without returning false, that means this is a palindrome, so return true by default. So you see, we have used the negative logic here, okay? We've used the negative logic. So it will terminate when it meets the first part of the word that is not a palindrome, or that disqualifies the word as a palindrome. With this said, let's test our palindrome function. So we're going to say console.log Anna is palindrome. Then we will say true or false. So we're going to call is palindrome that takes in the word Anna. Okay. And let's do the same for another word, marrel. Okay. Is marrel a palindrome? No. But let's see if our program is correct. Okay. So we will run this, and you see we still have the GCD one that we did up here for the find GCD. But then Anna is palindrome, true. Mariel is palindrome. Mariel is palindrome, false. So now you know how we use functions, and then we have used a loop. So well, I can tell you right now, you have the basic elements required to be a programmer. The next thing we will be working on throughout the whole course will be how to think. How do you come up with these algorithms, right? I think that's the next big thing. So now how to think in that line, let's have this last exercise. This one says write a function that converts hexadecimal numbers to decimal numbers. And I've given you a hint. So please write your function and paste your code in the comment. I'm going to look at it, or you can share the link to your GitHub. In the meantime, I will solve this in our next tutorial. Have a great one.